Welcome back. We're going to be looking at the conservation of momentum today. And in order to do that, I'm going to need the little law and what it says. Now, what this means is momentum after has to equal momentum before. It's conserved. It doesn't go away. Kinetic energy can be transferred into other forms of energy, but momentum can't. Momentum can be transferred from one thing to another, but it cannot be done away with. So here we have an air track system. We have, in this case, I let these two be the same velocity just for the illustration, and then they have the same mass, so that we'll get, as you can imagine, they'll hit each other and it's fully elastic, and then it bounces off, they change direction, and they take off that way. All right, so it's an easy thing to follow. And I did a little simulation where I programmed the parameters to be just like this. So let me bring that up here. Here we go. So they have the same velocity, just different direction, and the same mass. And that's what we would expect. And there's no friction to take into account or anything. This is just like an air track that you've been working with. So, all right. From that law, we can create this nice little equation. And it just means that before has to equal after. So the blue, that's the before and after for the one mass, and this is the yellow, the before and after of the other. And so V, that is the after, and this, the U, that is the velocity before. Okay, so not very complicated. But you do have to keep track of what you're doing. So let's take an example of a real problem. We have, again, an air track. We have two blocks that are floating on it. They go at each other, different directions, but the same velocity. But the one has 400 gram mass, and the other has 100 gram mass. Now I've programmed a little simulation to demonstrate this in case you have a hard time with it. Here they go. Same mass, or I'm sorry, different mass, same velocity. Now you can see the red one, it was the bigger mass, so it kept moving. Okay, and the yellow or the blue one was the lower mass, and it took off kind of quick. But they started off with the same mass, 0.75 meters per second. Okay, just the one was facing this way, and the other velocity was taken off that way. Okay, so one would be negative. All right, so let's take a look at this. We know the law of conservation of momentum applies. We know that this equation here will be very useful to us. And we need to find the velocity of that one. In other words, the one that took off to the right in the simulator kind of fast. All right, so let's see what we can do with this. We use the equation, and let's first put in everything we do know. Okay, we were given an awful lot of information here, and in fact, there's only one thing we didn't know, and that's what it wanted us to go after. It wants the velocity of the little carriage that took off to the right after the collision. Okay, so now it's just a bunch of numbers. I hope you can follow these. If not, just pause. I've color-coded again as usual, so you'll be able to see, okay, there's mass, there's velocity, there's mass, unknown, then the mass before, there, and it just keeps going and filling in. Now this is important, this negative there. You have to decide what's positive and what's negative. We could have reversed everything and had everything on the other side negative and then the one thing positive, but easier just to change one thing. And on the right side, it's just easier in a collision to let only one thing be negative if that's the way it turns out. But it doesn't matter. You can decide what's up and what's down and what's right and what's left. So just go ahead and do what's easiest for you. All right, so once we have that, then let's just rearrange things and we get our little solution. It's a very simple math problem. Everything's just numbers and simple things multiplied together. So the velocity of the blue one, and I'm going to bring it up one more time just so that you can see it. Okay, we just found the velocity of the little blue carriage there that is getting clobbered by the fatter red one. Okay? All right, see you next time.